Well, good evening and welcome. Welcome to our live stream. The nerds getting together. I hope you all had a fantastic public holiday, long weekend. As usual, the comments area is open for your questions or comments. And I'll stick a comment right in there now so you can see where it is. And without further ado, it's actually great to see you and spend time with you all again. And I realise it's short notice, so I'm not expecting many people to get here, but I really wanted to get this done in a live way because then I can put it on and explain exactly what this event is all about. So without further ado, let's get into it. So the first thing I want to talk to you about is, let's just get it out here, is about this diagram here. And if you remember this, I posted this some time ago and hopefully you see this quite clearly. So just going back to some basics before I get into what is actually causing this cold weather. So if you remember, I put this out some time ago and it basically gives you the cross-section of the atmosphere and what are the drivers in the atmosphere. So in the lower atmosphere, you can basically say that the lower atmosphere is actually it drives summer. So it's the heat on the ground causing air to rise. That is what drives the summer weather systems. It's the hot air rising from the ground. But winter, we pivot from the surface, we actually pivot to the upper levels. And you can see here on my diagram, these long-term weather zone. So this is the weather zone on the surface here, and they're all very short-term stuff, as I said, hot air rising. But in the upper atmosphere, it's these longer term drivers that really drive, especially in winter, because that's when we have the pressure cells that we've talked about before, the Hadley cells and the other ones. They shift around, and the feral cells, which is the cold cells, the Hadley cells are the warmer sort of tropical, subtropical cells. The feral cells are the colder air cells. They kick over and they drive winter. And they are very much driven by these upper weather systems, the jet stream, and these long wave troughs and these upper cold pools. As we've seen recently, they come up and they influence us quite significantly, and they drive weather right through the cross section of the atmosphere, not only from up, but in the upper levels right through to the surface levels. So let's get into what the world is going on, and there is an extraordinary potential cold event coming up. So first of all, let's have a look at the satellite picture. So if you look at this and you just think, oh yeah, that's pretty, but anybody who's knows about weather, is trained to look at satellite pictures, you'll recognize a couple of key features straight away for a start. The intertropical convergence zone, or the monsoon trough, is well in the northern hemisphere now, which is where it should be. It's moving through the Philippines, and it's also got an arc or a trough of low pressure here up through the Bay of Bengal, up through Vietnam and Thailand and all that sort of stuff, and that's starting to form that convergence in that area in response to summer, of course, and that's where it should be. Come back. In the southern hemisphere, I'm not sure what's going on there, peeps, but we'll find it, work it out. Let's refresh it. It's probably just downloading a new. Here we go. It's downloading a new image. In the summer hemisphere, we've got a couple of very interesting series. So wherever you see a satellite picture that has these dotted clouds, that's extremely cold air, extremely cold air. And to get that sort of pool of cold air, which is taken basically from the continent of Antarctica, you can see this wispy cloud here, how it's curving up, and it's actually dragging that cold air off the surface across. And it's the cold air interacting with the warmer or relatively warmer sea surface temperatures, which gives us this dotted cloud effect, because it induces convection, because obviously there's a temperature differential, and of course that creates cloud. But because the air is very cold, its ability to hold moisture is obviously a lot lower, so you get these dotty looking clouds as opposed to these massive clouds you get up in the tropics. There's big cumulonimbus, all that sort of rain bearing systems, because there's a lot more moisture, the air holds a lot more moisture, so there's a lot more clouds. So the first thing you can see is there's dotted masses everywhere, quite consistently, right across there. You've got one which is quite far up, look at that, way up into the Pacific, which is going to be interesting because that's going to drive La Nina quite significantly when it comes to summer, because that much cold air that far north. If you look at that, that dotted cloud there is akin to being up almost into central Queensland. That's how far that cold air has travelled up. So that's a significant temperature, cold front. And you've got some dotted cloud here, not really strong. And then you've got this reasonably strong change which is coming through us. You can see this dotted cloud. And then you've got this really nasty looking one here. That's a very strong cold front. And it's these series of cold fronts here that are going to drive our weather for at least the next 10 days. And they've got to do with a couple of systems. Obviously, the surface you have these cold fronts, which is the boundary between the warmer air and the colder air, and this is where the atmosphere is actually trying to equalize or stabilize the temperature differentials across the globe, so it sucks the warm air towards the poles. And of course, in physics for every action there's an opposite and equal reaction. So as the warm air comes towards the poles, the colder air gets displaced and comes towards the equator, and that's the way the heat balance is budgeted for the Earth. That's the surface. So you've got these cold fronts, and that's the boundaries, as I said, between the warmer air and the colder air. But what drives these surface systems is what we're going to look at now. So we'll look at the pressures, quickly have a look at that. And you can see, there's significant low pressure systems. Well, I mean significant. You got 980s, 964, 973, 934, which is like a category 5 super, like a severe tropical cyclone or a hurricane. If that was in the tropics, and you can see how the isobars are squeezed extremely tight. That's extremely windy, and I'll show you the wind map in a minute. You can see there's very severe winds, and again a 972 low up well into the South Indian Ocean, or South Atlantic, sorry, heading towards Africa, southern Africa. These systems are all driving at the moment, and I can show you what's causing it. So what we'll do next is we'll actually just go to the winds. We'll have a quick look at winds. You can see how these winds are, these severe systems with these winds, and the roaring 40s, which is where this is, and the 50s as well. The 40s and 50s this is quite natural because it's the bridge between the warmer tropical and subtropical systems to the north, the Hadley cells, and then the Ferrel cells, which are these colder ones. And this is the bridge, the roaring 40s, which is where the pressures are trying to equalize themselves, and because they're squeezing together, you get these extremely strong bands of winds. So what's going to cause these to move actually north quite a bit is the upper systems. And as you know, hopefully you've been listening to what I've been telling you about, and I will zoom in a bit now so you can see it a bit more in detail. It's caused by the impacts and the interaction of the Antarctic vortex, which is a very band of very strong winds. And if I zoom out again, I can drag it down across to wind, and I'll change the level for you. You'll see when I get to way up into the upper atmospheres, this band. Now see this white band here, it looks linear. It actually wraps around Antarctica, and this is part of the Antarctic vortex. Or the polar vortex, because both poles have them, and this is again part of the Earth's attempts to heat balance or balance the heat budget across the Earth. And these winds rage in the upper levels. You can see they're 160 knots plus, rushing around, in response to the Earth trying to manage the heat balance, the heat budget. And so that wraps around the Antarctica normally, and in summer it's actually quite compacted. It sucks back in towards the pole itself because of the warmer air to the north, tentacles up towards Australia, and to obviously the continents in the southern hemisphere. And this is when we start to get this interaction between the Antarctic vortex and us, and the interaction between the Ferrel cells and the Hadley cells. All this stuff sort of comes together. Now it's usually not that often, but we're going to see an extraordinarily long period where this happens, and you can see already to the west just how high the Antarctic vortex is, and it's quite displaced. It's way a bit further north than usual, and you can see already it's almost just over the very southern coastline of Africa and South Africa, and again it's going almost across South America, and right across here. And this is really your 10 days or more of cold weather, right in that little picture there, that yellow. You can see it just been bulging out towards us. And what that is normally, it's in response to, is a couple of things. It's obviously temperature imbalances. So we'll go out of here, and I'm going to go and show you this, the picture. We'll get into, it's about, we're talking about 700, let's go up there, about 3 kilometres up. It's pretty going to be greatest impact. And you can see these winds burning around, but this is the temperatures of what I want to show you. So, as I've talked about before, obviously Antarctica extremely cold, and what happens is the Antarctic vortex, it's like this the sea. I mean, atmosphere has fluidic properties, exactly like you see water. So just like in water, there's waves, there's tides, there's oscillations, there's rip currents, everything like you see in the sea. And if you're a sea dog on here, welcome and thanks for joining us. You can apply what you see happening in the ocean to the atmosphere above you, except it's obviously a lot more invisible. The effects are a little bit more tricky because there's a lot more things at play. But it's actually the air has currents, and the currents are pushed to and fro by a lot of different things. But essentially, it's the balancing of the heat budget, and it's obviously where there's been warmth and the cold comes from the Asian subcontinent. Recently, as the monsoon always it does before the monsoon starts to get established, there's always need a period of heat. Like, ignore the media reports about, oh my god, it's the end of the world, see, climate change is real because all this hot. Putting aside climate change, I'm not talking about that today. Heat in the tropics before the monsoon is absolutely necessary, and it's a mandatory part for them to get the monsoon. And why is that? Because when there's lots of heat, the air rushes up and air has to rush in to replace it. Voila, you have the monsoon. That's what the monsoon really is. It's just a word that means wind. Rain bearing a deeper process, which is the monsoon, which is driven again by the heat balance budget. It's part of the Earth's way of balancing the heat and the cold. So when you see all that extraordinary heat in the subcontinent, then Earth's response is to drag all this cold up because it's cold in the southern hemisphere because it's winter, and that is exactly what we're seeing. Simple as that. Now, it's easy to say simply. The complexity then comes to exactly how it happens, how it comes to play, what means, all that sort of stuff, and you get into a lot of atmospheric physics and science. The sea acts like it has fluidic properties, and so you'll see these waves. And if I just get this now, so this is the level about 3 kilometers above. This is the one that's predominantly going to drive this event. If I go a bit higher for you, you can see what I'm talking about. You'll see it very clearly. Just the extreme cold that's coming up. So that's probably a little bit too high because the pinks get lost. I mean, look at that. Those temperatures here, minus 53 is looked at way up to almost the southern. There's minus 40 over Sydney's tonight, and that's why it feels so freaking cold. These are extraordinarily cold temperatures. Extraordinarily cold temperatures, and as I said, they've been sucked northward. So when they sucks northward, the natural response of the Earth trying to balance that budget is very cold air upstairs. What happens is that it sucks air up from the surface to balance that out, and so what we'll see, if I just pop down a little bit lower, when I go to, you'll see here is these cold areas. So extremely very cold areas. You can see how it's that light, the aquas are being sucked down ahead of the cold troughs, and then cold fronts, and then behind it is extremely exacerbated by the fact that the polar vortex is so far north, because of a whole range of things. I'm trying to get that 700 because this is, well, I mean 600 too, like it's 4Ks up. It's still very much going to drive this process. And so what we're seeing is like this extraordinary cold air above us. So this is the air as we see. This is the temperatures. What I'm going to show you now is actually the pressure. So just bear with me because fortunately I drill through some layers here in Windy. So here you go. So what I was talking about before is about the attempt to balance the heat budget. Encroaches the Southern Ocean, gets a bit closer to us, and this is what it generates. All this in front of you here, these giant, all that blue and dark blue are massive areas of low pressure. I mean, massive areas. I mean, you are talking about a low there that is the size of Australia, or bigger, at 934. So that whole area there of thousands and thousands of kilometers is one huge extractor fan. And of course, as the atmosphere and the principles of physics, for every action there is an opposite and equal reaction. So what's happening is that these lows are sucking all this cold, like they're sucking all this air out. There's this very cold, dry, dead air, and they're dumping it then across in the feral cells, which are just to the north. So that's what we're seeing here. So that all this high pressure here, it's not very strong. It's only 1,030. Like, it's not overly significant. But when you have 1,033 to 900, so that there is, what's that, 100 hectopascals difference between those two systems. This is where you get these huge winds. Trying to equalize itself, and trying to sort out what's going on. And that is what's going to lead to this extraordinary cold outbreak. It's not going to be, windy, coldy, snowy type cold. It's going to be bitterly dry, windy cold that's going to I feel like it's going to rip the flesh off your bones. And it's not just for a couple of days. I'm talking about to the end of next week at this stage if the models are correct. And not only that, as I'll show you very soon, it's not just like 16s or 17s or 18s. It's a little bit uncomfortable. Yeah, might have to wear an extra jumper. No. Extraordinarily, tonight's model run of EC, Mr. Consistent, for Tuesday, Wednesday, Thursday, for the Sydney Basin of 13 degrees. Yeah, you heard me right. Max temperatures of 13 degrees. There's a bit of dropouts, is there? I think it's because of, yeah. I'm sorry about that. It's Facebook glitchy tonight. If you are getting some dropouts, I'm sorry. There's not much I can do about it. It keeps telling me there's a latency issue. It's not my end, their end. So going back to what I'm saying, so next 13 degrees, like that is, you want to talk about ice bombs, that sort of stuff. That's hyperbole. By using hyperbole, they have to use animated, pictorial language like that to get people's attention, to drive clicks. That's understandable. Believe me when I say it, when I show you, 13 degrees it should be a cold wave. There should be literally some warnings about cold because it is going to put our most vulnerable at risk. It is cold. It is not going to just be cold. It's going to be blisteringly cold because there's going to be a very dry, gusty to strong wind with it, which will rip every shred of heat from your body. If you're outside, it's hot, but you can cool down from heat. You can hop in the water. You can escape it. That sort of stuff. Cold is extremely hard to evade. It's extremely hard to get rid of. It takes a lot of energy to turn cold into warmth. It's a lot of power, a lot of that sort of stuff. It kills things. It kills plants, it kills animals, it kills human beings. Like cold is pervasive, and if you look at statistics, cold kills a lot more people throughout the world than heat does in any given year. And so you should be more fearful in everything. Like it creeps into your house everywhere you go. It's cold. And this is literally what we're looking at. Like I am animated. I'm using animated speech tonight for exact reason, because this is extraordinary. I don't think I've seen such a cold outbreak in a long time. That's not from snow or cold fronts or like a bit of snow up in the Blue Mountains. Oh my God, we're getting excited. This is almost like if you were in Casey in Vostok in Antarctica, like they don't get lots of rain and snow there. You think you're going to Antarctica and it's always just snowy and that's the stuff. Actually, no, it's more day after day after day. Yeah, you get their blizzards, they get snow every now and then, but it is more just that dry, skin destroying cold, which is what we're going to see a taste of it because of this setup. So what I'm going to quickly show you through, this is how the pressure system is going to work out. And you just watch these lows just like a train. You just look low after low, and like you think, yeah, this one's a big one, and look at the next one before it, and it's even bigger. Like it's even bigger, and the high gets stronger and stronger because it's just dumping this cold air that these systems are generating and dumping it all over us, which is going, and there's just very low pressure, so it's just going nowhere. And we're going to Saturday, and you can see that just the cold air just continues on, and go through into next week, and you see massive Tasman low, and what that's going to do is actually work with this high, and so these cells here in this massive area here are dumping dead dry air in this thing here, and the lows, and picking that dead dry air up and then ramming it right across the coast and for days and days and days. So that low doesn't go very far, and it's deep, like 990s. Look at that, 994, like not moving very far at all. Still there on Wednesday, and still there on Thursday. Like it's just really not moving very far at all. And then you got again another one moving through, and then another one, and then ginormous systems over here. Like it's just, once you get locked into this pattern, the ground cools quickly, and then the ground supports this, because when the ground's cold air can move, it starts to reside there, and you get high pressure forming, and that just reinforces that whole cycle. So we'll zoom into what I want to see now is we'll zoom into Sydney. We can get out of the wider spread pattern, and we'll go in, we'll get out of the pressures, and we can just show you, I'll show you the temperature we'll look at temperature stuff like that. We'll go to quickly have a look at change the pressure. We'll look at the wet bulb temperature for a start, because this is where the feels like. And so what we're looking at here is I can't make this a bit bigger, can I? Oh, I can actually. It might help people on the stream. Hopefully that helps you a bit better. Okay, so what you're looking at here is the colours are obviously the feels temperatures, the feels like, or the wet bulb temperature. So the darker yellows are obviously warmer, and the lights and the whites and that are cold. And like this evening, just tomorrow at 10 a.m., you're looking already 9 degrees across the basin, 11 degrees. It's going to feel chilly. And then look at that. Look at those whites. This is after the change hits, is what I'm promising you. Look at that, 4s, in the S, 6 degrees at 6 o'clock at night, 7 degrees at 7 o'clock at night. It's going to feel 5 degrees. It's going to feel nasty. And then of course you're getting into like minus temperatures now, and you can see like it is cold. It's going to feel bitterly cold, and that's just tomorrow. Like this is the first taste of it. And then we go through to, I'm going to show you next week, so it's going to be yellows and ups and downs, but essentially it's going to stay in that very, very, very low teens to single digits, basically from tomorrow right through the outlook. And then to next week, it's just, like, it's 3 o'clock in the afternoon, and it feels like 7 and 8 degrees. I mean, I wasn't using flowery language to tell you it's going to be cold. It is going to be cold. It's going to feel freaking cold. When you got 3 o'clock in the afternoon, that's normally your warmest part of the day, even in winter, like still feeling at 7 and 8 degrees at 3 o'clock in the afternoon, it's gonna rock your socks. And look at Wednesday, 5 degrees in Sydney, it's just 7 degrees at lunchtime on Wednesday, 7 degrees. 9 degrees in the afternoon, at 5 o'clock. Wow, it's lovely. It's 9 degrees. Woo! Go out there in a pair of Speedos. And then looking into Thursday, the same, you're still single digits. Like we're Thursday afternoon now, and it's still feeling like 8 degrees. Believe me when I say it's going to be cold. And if I click on Sydney here, this gives you one temperature. So this is just like the EC's. I'll put the 1 hour forecast out because it's a bit more detail. You can see tomorrow we'll be saying that change is going to arrive around there somewhere 1:30 to 2 o'clock. As I said, chance of a coastal shower, but it's going to be pretty. It's going to be pretty windy with gusts. And so, just a quick aside, I'm just jumping around a little bit. Hopefully the stream's a little bit more consistent now. It's just really annoying. Facebook just drives me bonkers. When you hear me say that it's going to be gusty winds, you can see the difference here. The first figure here is consistent winds, so that's going to be up to 20 knots. That's not too bad. But then you go from 18 to 34, or 17 to 30. That's when it becomes gusty, because you've got a pretty solid, consistent wind speed, and then suddenly, whack, it just comes out of nowhere. That's what I mean by gusty. When you have like a windy days, when I say moderate or strong or damaging, it's when both those bars are that pinky colour, which means the winds are consistently solid, strong. So there's a little explanation for you. When I say gusty, so your winds during the day aren't going to be, they'll be just solid, but then you'll have these bursts of wind. You think, where the hell did that come from? Anyway, so let's look across. So we got cold nights, not to be expected, 14 to 15 degrees on Thursday, max, 14 to 15. That's bloody cold as it is. Friday, again, 14 to 15 max. And going across the week, interestingly, EC's going for some showers now from Friday night through to Saturday morning, and even Saturday lunchtime, which is interesting. You didn't have that before. Look at that, 13 to 14 degrees on Saturday. That's the max, 14 degrees. That's Saturday. This is before even the main part starting. And then we go a little bit, it's warmer on Sunday. Wow, it's 15 degrees. Enjoy that. And look at this. I'm hoping now you can see why I did the live tonight. And this is just an output now. It's been like this for a couple of days, but the temps have been going down and down and down. This is freaking insane. Look at this. Every day, 13 degrees max. And I'll just go and change here, and I'll change this, to, I need to get down here, just so you can actually see, and get out there and get a temperature, just so you can see. And go back to Sydney, because it'll give you, go away, it'll just give you the, alright, let's go across. It'll give you the inland temperatures as well, so you can see you're getting a picture of everything. All right. So Monday, 10 to 13 degrees, and if I click on there, like it's 13 degrees across the whole basin, 12 degrees in places. It's cold. 11 degrees, so 11 to 13, 11 to 14. You know, that's cold. And then you go Tuesday, 13 degrees, 12 to 13. 12 to 13 degrees all day. Wednesday, it's 12 to 14, maybe 13 on the coast. That's changed since we just did that, didn't it? Because that was 13 before, now it says 14. That's just bizarre, unless EC's just updated. Has it updated? No, it's 2 hours ago. That is weird, bizarre. And then it goes back to 13. Interesting. Anyway, that was 13 before, and I think that's 13. I think that's a glitch with Windy. I think that's an older run. That was 13, and that was 13. And look at these overnight temperatures. 5 degrees on Friday on the coast, on the sea level. 5 degrees. You've got sevens, you've got 8s and 7s. That's not over cold, but 5 degrees on the coast is cold. And it's only June, so we're only just hitting to winter. So people are saying, oh, but it's winter, it's supposed to be cold. We're not supposed to be getting this in June. June is normally that transition month where you still get a few nice days and you get those cold fronts start to come up and things start to cool down. And then by peak July, you're starting to get those westerlies, southwesterlies, the dead cold, the real deep cold. This is deep cold when you're looking, basically we're not getting anything above sort of 14 to 15 degrees as of tomorrow until next Friday. That is significant cold. Significant cold. So that is what's up to. So hopefully I've explained it, and hopefully the stream hasn't mucked you around. I don't know what's going on with this. It just drives me bizarre. I will turn to your questions now. Let's go. Had the heater cranking? Yeah, you're going to need to have the heater. Will the western suburbs get these stronger winds like coastal areas? No, Brad, normally because the Blue Mountains actually does provide a good, not only good rain cover, but also you can see that most of the winds you can see skip it and then they again appear on the coast. Even that's just bizarre. That's even Fridays when I'm looking at Friday. So if I go to here, you can see what I'm talking about. These are gusts. Look at that. See, dead area. Thanks to the shadow, the wind shadow of the Blue Mountains. And then you can see it basically bumps over, and then you can think on the downslope when it comes back down and it just peaks across the coastal areas. So when we complain on the coast that it's windy and it's gusty, and you guys in the west thinking, it's not that windy. Hey, what are you talking about? Oh, fizzer forecasts. It's actually, this is what happens, exactly what happens. You guys get particular, and you can see on the western or the leeward side of the Blue Mountains, because the southwesterlies, they get absolutely hammered as well. And that is just going to feel absolutely horrendous for at least 11 days, 10 days. And of course, we'll keep you updated as things develop, but I'm not overselling it, and I'm not using hyperbole lightly, but there is literally no flowery language left that I could use to explain or to describe to you what is going to come and is going to descend upon us for the next 10 or 11 days if the forecasts come out. And looking at the longer term pattern, there's no reason why they won't. It is going to be cold. It is going to be cold, I don't know, I can't remember the last time I was so cold like this. We've had bursts of it every now and then, and it's but I can't remember a time when it's 2 weeks consistently bitterly cold like it's going to be. There's going to be wind, unfortunately, Glenn, but there won't be hardly any rain at all. There'll be no rain. In fact, look, it's completely dry in the whole forecast, right through the bit of cloud around. The occasional shower, which is this weekend, but there's nothing heavy. But then if you go into next week, just beautiful, sunny, freezing cold days. You'll think, oh, it's sunny. Yeah, it's going to be. Just coincidentally, I actually happened to be in New York for one of those polar vortexes that you might have heard about at a time, and it was actually minus 17 Celsius when I was there. And I was expecting to be the day after tomorrow it was, where there was the ice forming on the Statue of Liberty and people dropping dead in the street from the cold. It actually wasn't anywhere as cold as I thought it was going to be. It was blue skies, there wasn't much wind, it was just bitterly cold because it was very still, and obviously there was a lot of dead air coming in. That's essentially what it's going to be like the whole from here to next week. Obviously not minus 17, but the process is still the same. high pressure systems dominating with dead cold air just being dragged down from the upper atmosphere across us, and windy days in response to a low that's offshore, just dragging up that dead cold air across us. Hopefully the sound's back, Mark. Sorry, I'm not sure what's going on tonight. I honestly don't know. It's just good old Zuck. He doesn't like cold. Doesn't make him any money, so he's got to keep it nice and warm. Alrighty. I think any more questions? Again, please ask them in the chat, and I will definitely answer them for you. I'm going to get off now because I said only half an hour, and I promised it would only be half an hour. It's just going to be blisteringly cold, so the video will be available, and that's one of the reasons why I wanted to do it live. So rather than trying to explain myself in a post and that sort of stuff, it's probably better I just actually voice it, and you can watch the information, you can read it and see how it's interpreted and what it means and why I say things when I do say the things I do. Otherwise, thank you so much for your support, and I do apologise again for those dropouts tonight. It's just so annoying. I've actually been onto my ISP today. I've been onto the NBN. I've been harassing them about my upload speed and saying what's going on. They keep telling me there's nothing, the issues. I'm at a loss now. So if anybody out there in Nerdland is an IT expert or sort of stuff, please inbox me and see if you can help me with what's going on to fix this, because I literally am at wit's end. I've gone through everything, other side from throwing my modem off the balcony, and it's a Telstra smart modem, so it's reasonably brand new, and looking at something a bit more future proofing. I honestly don't know what to do, and I don't have lots of tabs open. I don't have lots of information open to try and drag the system down, and perhaps it is my system that's doing it. Maybe I should be mapping the CPU and just seeing what's going on. All right, I'll leave it there. Enjoy. Please let me know. Again, any questions, anything you need to have. Troy definitely knew he's going to be part of that, as you can see. Let me show you. I'll quickly look at Newcastle for you. It'll be obviously that tad bit warmer because it's a tad further north, but even again, look at your next week. You got 14 degrees max on Monday, 15 degrees max on Tuesday, 15 on Wednesday, 15 Thursday, and say 15 Friday. For Newcastle, 15 degrees max is pretty damn cold. Saturday, you're looking at 14 degrees max, maybe 13 to 14 max, and a few showers. Like, it's going to be cold for you guys too. Like, it's going to be freaking cold. And for people in the Gong, I'm imagining it's probably going to be that tad colder. Although they tend to get 12 and 13s. Probably the same as us, not too bad. I mean, not too bad, but the same, it's going to be cold. Yeah, it's going to be cold. All right, I'm going to hop off. Thank you so much for your time. I greatly appreciate it. Apologies if there are short notice and the sound issues, but we're going to, I don't know, I'm just going to jump off the balcony. That might help fix it. So someone listens to me. Thank you, Chris. Welcome, by the way, too. All right, thank you so much for all you people who joined. It's so awesome to have your company on a chilly Tuesday night, because it is cold. It's going to be cold, and we need tomorrow, so I'll keep you updated again, and I'll keep you updated about this icy outbreak that we're going to have. It is going to be icy, as you can see. I'm not just talking up for nothing. It is looking absolutely, and do not believe the ridiculous temperatures the Bureau have on their page. 19 degrees tomorrow. If it didn't get to 19 today, it is zero going to get to 19 tomorrow because of the change coming. And it's definitely not going to be 17 and 18 degrees going forward. It just angers me so much, and I don't want to get into, the climate debate, because there is so much nuances to climate stuff. And I really just feel it's been hijacked by the grifters, and as opposed to the real science looking at it. And it's now become an industry as opposed to science, and any true scientists will be horrified at the fact that people are making a living now of something that really should be just focused on scientifically. And I think the last couple of days and these next 10 days hopefully will absolutely show why it is a grift and not science anymore, and reset a few expectations about what our atmosphere does and why the climate does what it does. And I will have some information about what I think's been going on the last few weeks and why we've sort of experienced this stuff. When you look at the drivers, the climate drivers, there's nothing really that stands out. ENSO is in neutral, IOD is in neutral. None of those are really impacting us anyway this time of year. Even the SAM, the Southern Annular Mode, which is the the measure of how active the Southern Ocean is, it was actually in the positive, which means we shouldn't be getting any rain at all. We should have seen nothing really, and yet we had troughs, two lows, two weekends in a row. We've all been well above average for our rainfall. So again, it's wrong as well. So there is another driver out there. We need to discover it and go from there. And I think definitely it's called for me it's the Tasman Sea Dipole or something along those lines, and it's the Tasman that drives it. Anyway, out of your hair. Thank you so much for your time. It's been awesome for you to keep me company, and I greatly appreciate it. And you take a great evening. Have a great evening. Take care. Stay warm. And I will catch you on the flip side, and I'll definitely chat to you tomorrow and keep you updated about what is exactly we can expect. Have a great evening. Stay kind to each other. And for now, laters.